So this is unit 10.1 homework. So before we get too far, I'm going to give you like just a quick summary of the notes. And so if you need the notes, you can go back to it. But we learned this, and the only reason I remember is because we're teaching it right now. We're talking about growth and decay. So a couple things to know about growth and decay. Let's talk about growth first. So growth, any kind of, so this is exponentials. Any kind of exponentials, the domain or the input is always going to be all reals. You can put anything you want in for the domain when we're talking about exponentials. The range is going to have an asymptote. And so we're going to look for an I never spell it right, so let me write it right. Asymptote. So we're going to look for where it kind of skids along, and that's going to be our asymptote. And so let's first look at the graph for growth. So if we're talking about growth, and this is kind of very relevant to what's going on right now. So we're still kind of in a growth model for the coronavirus. We started out low, and we started to grow slowly, and then we went up very quickly. And so a growth model starts out low, and it goes up quickly. And what you're looking for is where's the boundary that we're not crossing, the asymptote, to find the range. And for this one, that color doesn't show up very well. For this one, it's actually the x-axis. So it's kind of skimming along the x-axis, but it's never crossing it. And so the range for this one, there's a couple ways you can write it. You can just write all positive numbers. Or you could say y is greater than 0. So no matter what you do here, you're never going to get an output that's a negative, no matter what you put into it. Does that make sense?
Yeah.
Okay, if we're looking at the equation of a growth, there's a couple parts to it, but generally it looks something like this. Y equals a, and then there's a base number raised to the x. So if the base number, the b, whatever's raised to the x, is greater than 1, it's growth. Oh, you can't see that. So that's for growth. So either when you look at the graph, it starts low, goes up high, or if you just look at the equation, if this number here in the raised to the x power, the b, is greater than 1, then you have growth.
Okay.
Does that make sense?
Yeah.
Okay. And then the second thing, are you still writing?
No.
Okay. The next type we talked about is decay, and this is where we're trying to get to. A decay, again, our domain, I don't know why I'm saying so much. Our domain is going to be all reals. And our range, again, is going to have some kind of asymptote that we're looking for. The difference in the drawing is that we start out high and we end up low. So we start out high and we end up skimming something like that. So our goal is to get there with the coronavirus. We'll never completely eradicate it, but we want to get it so low that it's almost to 0, or whatever number we're trying to aim for. So this one I drew just a little different so you could see a different asymptote. And so this one's asymptote is here. It's skimming along 2. Well, I was trying to make it skim along 2. And so that means for our range in this problem, you can say all numbers greater than 2 Or you could say y is greater than 2. So that's the range. For this one, if we're just looking at the equation, the base is a number between 0 and 1. Whoa, I don't know how to spell. So it's either going to be a decimal or a fraction. And we did this before.
Take down a little bit.
Yeah, this way. Like, how about like that? Is that good or is that too small?
Yeah.
All right, so that's going to get us to the first 5 problems on the homework. So let's do the first 5 problems on the homework, and then I'll give you a basic idea for the next part. Are you good to move on?
Yeah.
Okay. All right, so number 1 says y equals 3 parenthesis 2 raised to the x. So just by looking at that, our base number is 2. Therefore, that's a growth model. Our domain is all real numbers. And you can write that fancy R too if you want. And then to graph it, I'm just going to get my graphing calculator, put it into y equals, and use my trace function. So let's see if it's working. Some days it works well and some days it doesn't. I don't know. Okay. So let's see if you can. Okay. So there, I put it into y equals. And then just like we were doing last chapter, I'm going to hit graph. And then I'm going to use this trace button to get like 3 good points on it. So -2, move this over. So like it's about -2 and about a little more than half. And then if I go up a little bit, I'll go here. 0, 3, that's an easy one. And then it looks like 1, yeah, 1 up almost 6. So like that. So then I kind of have the basic idea. The big thing is to make sure it's not crossing that asymptote. Does that make sense?
Yeah.
And so then our range here, y is greater than 0. Or all positive numbers. Because my asymptote is right here. Does that make sense for number 1?
Yes.
So you could do it, you could look at the table of values, but I think it's just easier to use that trace button and get 3 good points on there.
Yeah.
Okay. 2? So number 2 is pretty much the same thing, except this time our b is 1/2. So because b is 1/2, this is going to be decay. So again, domain's all real because it's an exponential. Okay, and then I'm just going to use my calculator to, and then I know you know this, I'm just going to say this for anybody that's watching. So it's 2 parenthesis, if you want to put a fraction in, it's 1 divided 2, close parenthesis. the caret key, which is right above the division key, and the xt theta n, which is right next to your alpha key. And then hit graph. And we expected it to be starting up high and coming down low because it's a decay. And then I'm going to hit trace. So 0, 2 is where it's crossing the y-axis, so that's a good one. And then it looks like 2 and then a 0.5, so like there. And then I'll go up. Let's see. -1 looks like it's almost at 4. 1, 2, 3, 4. Okay, so it's something like this. Skimming again along the x-axis. Okay, so again, this is our asymptote. And so our range is y is greater than 0. I think that's all for number 2. Does that make sense?
Yeah.
Okay. Do you remember doing this at all in Algebra 1?
No.
We don't spend a whole lot of time on it. All right. So then 3, 4, and 5. 3 and 4 are pretty easy. Because number 3, the base is 6.5. So what is that, growth or decay?
Growth.
Yep.
No.
Number 4.
Okay.
Because the b is 9/10. Now number 5 is a trick question. You have to You have to remember the rules of exponents. So it's y equals 10 to the negative x. You might remember this, but we'll see. And then y equals, that really means 10 to the -1 raised to the x. Well, remember, anything raised to the -1 is actually a fraction, because we have to flip it down to the bottom of the fraction to make it happy. Or if you've forgotten completely, you can do 10 raised to the -1 on your calculator, and it's going to give you 0.1. So this is really 0.1 raised to the x. So that makes it a decay. Does that make sense? So it's kind of a trick one because of that negative up there. Okay, I'm going to go you may or may not need to write this down, but what we're getting into for 6 through 15 has to do with exponents and radicals. So I'm going to do a quick review of the rules of exponents and the rules of radicals. I don't know if you want to write it down or not. You probably remember most of these, but just in case. So let's start with exponents. And if you want more detailed, Miss Klanowski has it more detailed on her notes. So remember exponents, let me make sure I get them all right. A power to a power. And you've been doing this a lot. You probably I just want to make sure we haven't forgotten. Is we multiply exponents. Let's see what else. If we multiply like bases, then we add exponents. if we divide like bases, we subtract exponents. And then, I never know how to say this, negative exponents. I don't know how to, hey Jasmine. We're working through 10.1 homework, so I'm kind of giving just a quick review before we get to number 6 on 10.1. Have you started it yet?
I have not.
Okay, good. Do you have it in front of you?
Here, let me pull it up.
Yeah, that way you could just write this down as we go and then put it in there. And I recorded this, so the first 5 problems are recorded so you can look back at it later.
Thank you.
Negative exponents, I never know how to say in words. Basically, x to the negative 1 equals 1 over x. And like 1 over x to the negative 1 equals x. So we flip. So that's the best way I think I can explain it without, I don't know how to say it without tons of words that get confusing. Okay, so that's what we're going to have to use for what where we're headed right now. We're actually learning, this whole unit is about how to solve equations that have exponents variables in the exponent. So there's a lot. So we have to review what we knew already, and then we're going to head into logarithms, which are pretty cool. Okay. Are you good? Do you need to write it down, or need me to pause? So the other thing that's going to come into play a little bit is radicals. So I just want to do a quick, can I scroll?
Yeah.
Okay. I want to do just a quick review of radicals. You probably remember this because it comes pretty naturally at this point. But if we multiply a radical times a radical, remember it's outside times outside, inside times inside. So this would be 8 square root of 21. And if there was anything you could simplify, you would pull out your simplified numbers. Probably remember most of this. With the radicals, if you have 2 that have the same square root, like 3 square root of 2 plus this 4 square root of 2, then that you can combine like terms here, so that becomes 7 root 2. But they have to have the same exact square root for them to be added together. And I think that's all with the radicals. I just want to make sure that this is Algebra 1 stuff, but it's been a little bit of time since you probably have done it. All right, so you ready for number 6?
Yeah.
Okay. So number 6 is 3 to the root 3 raised to the root 3. So this is a power to a power, so we're going to multiply. And really what this gives you is 3 to the power of root 9. Because inside times inside is 9. And then you ask yourself, well, what's the square root of 9? Can that be simplified? And that's 2. Nope. It's not the square. Oh, I did this wrong. It's 3. Thank you. Yep. So 3 to the third is 27. They don't always simplify down to a nice number like that. That one just happened to. Does that make sense?
Yeah.
Don't sound so excited.
I'm tired.
Yeah. Okay, number 7. This one's one that's not going to come out nice. We have x raised to the square root of 2 raised to the square root of 7. So again, a power to a power, we're going to multiply. Radicals, we just multiply outside times outside. Well, there's 1s on the outside, and then inside times inside. So this just ends up being x to the square root of 14.
right? Then that would be the answer.
That's the answer, because there's nothing that can come out. You can't, x is not a number, so it's not like you can put that in the calculator and get, that's a terrible square. There. So that's just the final answer for that one. We're going to get deeper into this stuff, but for now, that's good. That's all we want. Okay, 8 is 5 to the power of 2 root 3 times 5 to the power of 4 root 3. So again, this goes back to the rules of exponents. If we have like bases, which we do, then we can add exponents. So then it's really 5 to the 2 root 3 plus 4 root 3. And then that goes back to the rules of radicals. If you have the same exact square root, you can add like terms. So this would be 5 to the 6 root 3. And that's it for now. That's all you have to do. Does that work? Are you okay with that?
I mean, like, I hate it, but it makes sense.
Okay. I think you might like the next, when we get to number 10, it's a little bit fun. I like it because it's kind of a puzzle, but you know, then again, I am a math teacher, so. Number 9 is x to the 3 pi divided by x to the pi. And we just talked about if we have like base, or no, if we're dividing like bases, we subtract exponents. So we have a like base, both of them are x, and so we just do 3 pi minus pi. And since they're like terms, we can do 3 pi minus pi to make it 2 pi. So it's x to the 2 pi. Is that good? Okay, the next part is the part I like. So get excited.
I'll do my best.
That didn't sound excited. Okay, so what's going to happen now from 10 to 15? We're trying to get them so they have the same bases. Because if the bases are the same, we can then say the exponents have a relationship. So our whole thing, we're not going to be canceling out the bases. It's a therefore statement. Since the bases are equal, therefore we can do something with the exponents. And that's how we're going to solve these. Okay? So the first one is number 10. It's an inequality. So 3 to the x is greater than 9. Now, you always want to look and see what I've given you, because I've given you a hint to know what the base needs to become. So the base needs to become 3. So how can we make 9 written as 3 to an exponent? Yep, so it's just 3 to the second. So because we have like bases, because we say 3 equals 3, therefore that means x has to be greater than 2. Because of the relationship of the bases, there's a relationship with the exponents. We're not really canceling it out. If we were writing this out complete, we would say because there's this theorem that says if 3 is equal to 3, if the bases are equal, therefore, but we're not going to write all that. So we're not really canceling out the 3's. We're using a theorem here. And so that's going to be our answer.
Use the exponents.
Yep.
If the bases are the same.
Yep. If the bases are the same, then we can use the exponents with the relationship that's been given. Okay. So number 11 is 2 to the 2x plus 3 equals 32. So as soon as I see that 2 is the base on this side and that the x is in the exponent, that means there must be a way to write 32 with a base of 2. And if I and I couldn't remember 32. I knew what it was between. And if you're not sure, I just start messing with my calculator and go 2 to the third, 2 to the fourth, until I get to 32. And this base is what gives you where to start, what your base is going to be. So when you do this, you get 2 to the 2x plus 3 equals, and 32 is to the fifth, 2 to the fifth power. So in this case, because it's an equation, because 2 equals 2, the relationship between the exponents means that 2x plus 3 equals 5, and now it's just a simple two-step algebra equation. Isn't that kind of fun? So then
I mean, that's more fun than the other
okay.
stuff, so.
Yeah, true.
So I don't know how many steps you need to take for this, but you can show what you need to show. But the final answer is x equals 1.
So with these, it has like different symbols. Like some of them are like greater than,
Yeah.
and some of them are like equals.
Yeah.
How does that affect it?
That just changes the relationship of the equation. If we of the exponent. So like in this first one, the 3's are still equal, but the relationship is based on what we had originally for the exponent. So in this case, because this side was greater than this, the left side was greater than the right side, the exponent on the left is going to be greater than the exponent on the right.
Oh, okay. I see.
In this one, it was an equal sign, so the exponents are going to be equal.
All right.
Does that make sense?
Yeah.
Okay. Ready to look at 12?
Yeah.
Okay, number 12 is going to be 3 to the, whoops, that's not right, 49, just did that one, 49 to the x is less than or equal to 1/7. Now this one is where we're going to have to mess with both sides a little bit. So 7 gives us our base. That's what our base needs to be, but we need them both as not a fraction. Okay? So for 49, most of us, and this is where your number sense comes in. If you don't have a good number sense, you got to pull out your calculator and start messing with the numbers. But you're going to see we repeat a lot of the same numbers. So this is going to be 7 squared to the x power is less than or equal to, and this is where I talked about negative exponents. So really, this 7, if I want a 7 and not a 1/7, I can rewrite it as 7 to the negative 1. So that's why I went over negative exponents, because sometimes you're going to have to flip it up to the top. In order to do that, then you have to put it to the exponent of a negative. So then what we really have is, because it's an exponent to an exponent on this side, you could skip this step that I did, but it's 7 to the 2x is less than or equal to 7 to the negative 1x. Because the bases are equal, we can now make a relationship between the exponents, and in this case, it's a less than relationship. So 2x is less than or equal to negative 1. And then we just divide both sides by 2. And then our final solution is x is less than or equal to negative 1/2. Oops, sorry, I didn't scroll up enough. Are you okay with that one?
Yeah.
Yeah.
Okay. So 13 is 4 to the 3x minus 2 equals 16. Now sometimes you have to do both sides like we did in the last one. In this one, though, 16 can be broken down to a base of 4. So we don't need to break down the 2 also. I mean the 4 also. So we can leave the 4. And 16 can be written as 4 squared. And then because 4 equals 4, we can say 3x minus 2 equals 2. And then it's just a,
X equals 4/3.
yep. Does that make sense?
Yeah.
Okay. 2 more and then we're done the homework. Number 14 is 3 to the 2x plus 5. Oh, I made this not enough room for me. Equals 27 to the x power. So as soon as I see 3 as my base, I know that, and again, you're going to see a lot of the same numbers. So that's why I know what they are. So 27 can be rewritten as 3 to the 3rd, and there was an x already up there. And then because the bases are the same, we can say the relationship between the exponents are equal. And when you solve it, I got x equals 5. Oh, sorry. Is that good?
Yeah.
And then the last one is 27 to the x power. See, again, 27 shows up a lot. Equals 3 to the 2x plus 3. 27 can be written as 3 to the 3rd. If the bases are equal, the relationship between the exponents are equal in this case.
I keep forgetting to add that X in the exponent.
Oh, yeah, if there's an x up there, make sure you put it on there. Is it going to rain today? Oh, I should unrecord.